It is not a good practice to simply tape over a damaged wire, regardless of whether the damage occurred before or after a pull. Firstly, electrical safety is a primary concern. Damaged wires pose an electrical hazard, increasing the risk of shocks, fires, or short circuits. Even a small nick in the insulation can create a pathway for current to leak, leading to dangerous situations. Secondly, reliability is compromised when damaged wires are simply taped. Taping over a damaged wire may not provide a reliable connection, potentially leading to intermittent electrical problems and equipment malfunction. A proper electrical connection requires secure mechanical and electrical contact, which tape alone cannot guarantee. Thirdly, the insulation of the wire is compromised. The tape used may not be designed to provide sufficient insulation, potentially compromising the wire's protection from moisture and other environmental factors. Electrical tape is designed for specific purposes, and it is not a substitute for the original insulation of the wire. Finally, taping over a damaged wire is considered poor workmanship. It may reflect negatively on the electrician's professionalism. Electrical work should always be performed to the highest standards of safety and quality. If the wire is damaged before a pull, it should be replaced with a new wire of the appropriate gauge and insulation. Trying to salvage a damaged wire is not worth the risk. Using the correct wire size is critical for safe and efficient operation. The appropriate wire size depends on the circuit's amperage rating and the distance the wire runs. Consult the National Electrical Code (NEC) Table 310.15 for ampacity ratings of insulated conductors. Replacing the wire ensures that the entire conductor is free from defects and can safely carry the intended current. If the wire is damaged after a pull, the damaged section should be cut out and the remaining wires should be spliced together using a proper splice connector and electrical tape. It is important to ensure that all electrical connections are properly made to maintain circuit integrity and prevent hazards. Splicing should only be performed within an approved enclosure, such as a junction box. All splices must be accessible for inspection and maintenance. Never bury a splice in a wall or ceiling without an accessible junction box. To make a proper splice, firstly, strip the insulation from the ends of the wires to be joined, exposing enough conductor for a secure connection. Secondly, use a wire connector appropriate for the wire size and type. Wire nuts are commonly used for splicing solid and stranded wires. Thirdly, twist the wires together tightly using the wire connector. Make sure the connection is mechanically sound before applying electrical tape. And finally, wrap the splice with electrical tape, overlapping each layer to provide a moisture-resistant seal and additional insulation. Always use listed or certified wire connectors. These connectors have been tested and approved for use in electrical systems. Do not use undersized connectors, as this can lead to overheating and failure. Always use electrical tape that is listed for the voltage and temperature rating of the wires being spliced. Avoid using general-purpose tape, as it may not provide adequate insulation or protection. Always ensure that the power is turned off before working on any electrical circuit. Verify that the circuit is energized using a voltage tester. Lockout and tag-out procedures should be followed to prevent accidental re-energization of the circuit. Use wire nuts, electrical tape, and other appropriate materials to ensure secure and reliable connections. A secure connection minimizes the risk of loose wires, arcing, and overheating. Electrical tape should be applied in a manner that provides a tight, moisture-resistant seal. Avoid stretching the tape too thin, as this can reduce its effectiveness. Do not exceed the maximum fill capacity of junction boxes. Overcrowded boxes can lead to overheating and difficulty in making proper connections. Consult the NEC for box fill calculations. Always consult the NEC and local electrical codes for specific requirements related to wiring and splicing. These codes are designed to ensure the safety of electrical installations. When in doubt, consult with a qualified electrician. Electrical work can be dangerous if not performed correctly. A qualified electrician has the training and experience to safely and properly install and repair electrical systems. Regular inspections of electrical systems can help identify potential problems before they become hazards. Look for signs of damaged wiring, loose connections, and overheating. Consider using a licensed electrical contractor for periodic inspections. Maintain accurate records of all electrical work performed, including the date, description of work, and materials used. This documentation can be helpful for future maintenance and troubleshooting. Always use the correct tools for electrical work. Insulated tools are essential for protecting yourself from electric shock. Use wire strippers, crimpers, and other specialized tools to ensure proper connections. Never use damaged or worn-out tools. Inspect tools regularly for signs of damage, such as cracked insulation or broken handles. Replace damaged tools immediately. Store tools in a dry, organized place to prevent damage and corrosion. Consider using a tool belt or tool bag to keep your tools readily accessible. When pulling wire through conduit, use a lubricant to reduce friction. This will make the pulling process easier and reduce the risk of damaging the wire. Use a pulling rope or fish tape to guide the wire through the conduit. Avoid pulling the wire too forcefully, as this can damage the insulation. When working with aluminum wire, use connectors and terminals that are specifically designed for aluminum. Aluminum wire expands and contracts more than copper wire, so special connectors are needed to prevent loose connections. Apply an antioxidant compound to aluminum connections to prevent corrosion. Follow the manufacturer's instructions when installing aluminum connectors and terminals. When working with high-voltage circuits, take extra precautions to protect yourself from electric shock. Wear appropriate personal protective equipment, such as insulated gloves and safety glasses. Work with a partner to ensure that someone is available to assist you in case of an emergency. Never work on high-voltage circuits alone. Be aware of the potential hazards of working near energized equipment. Maintain a safe distance from exposed conductors and other potential sources of electric shock. Use insulated barriers or guards to protect yourself from accidental contact with energized equipment. Follow lockout and tag-out procedures to ensure that equipment is de-energized before working on it. Double-check that the equipment is de-energized before beginning work. Use a voltage tester to verify that no voltage is present. When working with underground wiring, be aware of the location of other utilities such as gas lines and water pipes. Contact the local utility companies before digging to avoid damaging underground utilities. Use caution when digging near underground utilities. Dig by hand to avoid damaging the utilities with power equipment. If you damage an underground utility, notify the utility company immediately. Never attempt to repair a damaged utility yourself. When working with overhead wiring, be aware of the potential hazards of working near power lines. Maintain a safe distance from power lines to avoid electric shock. Use caution when working with ladders or other equipment that could come into contact with power lines. Never touch a power line. If you see a down power line, stay away from it and call the utility company immediately. When working in damp or wet conditions, take extra precautions to protect yourself from electric shock. Wear waterproof clothing and gloves. Use ground fault circuit interrupters, GFCIs, to protect yourself from electric shock. GFCIs are designed to trip a circuit when a ground fault is detected, preventing an electric shock. Test GFCIs regularly to ensure that they are functioning properly. When working in confined spaces, be aware of the potential hazards of limited ventilation and exposure to toxic gases. Ensure that the space is adequately ventilated before entering. Use a gas detector to check for the presence of toxic gases. Wear appropriate respiratory protection if necessary. Never work in a confined space alone. Have someone outside the space monitor your progress and be available to assist you in case of an emergency. When working with electrical equipment, follow the manufacturer's instructions for installation, operation, and maintenance. Use only approved replacement parts. Do not attempt to repair electrical equipment unless you are qualified to do so. If you are unsure about how to repair electrical equipment, consult with a qualified technician. Keep electrical equipment clean and free from dust and debris. Regular maintenance can help prevent electrical problems. Inspect electrical equipment regularly for signs of damage, such as frayed cords or loose connections. Replace damaged equipment immediately. Store electrical equipment in a dry, organized place. Protect electrical equipment from moisture and extreme temperatures. When disposing of electrical equipment, follow local regulations for proper disposal. Some electrical equipment contains hazardous materials that must be disposed of properly. Do not dispose of electrical equipment in the trash. Recycle electrical equipment whenever possible. Recycling helps conserve resources and reduce pollution. By following these best practices, you can ensure that your electrical work is performed safely and reliably. Remember, electrical safety is everyone's responsibility. Always take the necessary precautions to protect yourself and others from electric shock and fire. Always prioritize safety when working with electricity. Electrical work can be dangerous, but by following proper procedures and using the right equipment, you can minimize the risk of accidents. If you are ever unsure about how to perform a task safely, consult with a qualified electrician. Do not take chances with electricity. A small mistake can have serious consequences. Always double-check your work to ensure that it is safe and correct. Your safety and the safety of others depend on it.